Okay, so this example is simple. 4 fish. Okay, if you want, you can think of it as 400 fish, 1,000 fish, 1,000,000 fish. It's up to you. But the idea, you can put as many zeros on it. So, but 4 is easy to work with. So we'll start with 4. All right. Let's solve. Actually, let me think about that. Now, I'm going to hold off. We're going to do our solutions in a moment. Let's do it this way. So we have 4 fish. Now, you see this pristine lake, you're hungry, you want to fish, so you decide to go fishing. So when you go to fish, actually, let's graph this. Make a pretty graph. I'm going to make a big one here because we're going to have a whole bunch of things that are going to start to go on. And so let's see, this will be my black graph here. So black. Notice that, as it is right now, let's find the zeros, find steady states. Find the steady states. So in other words, what we do is we set y prime equal to 0. So y prime, which is 4a minus 4y. 4y minus y squared is equal to 0. If we factor y, I have 4 minus y equals 0. And so it looks like I have steady states of 0 and 4. Okay, I'm going to graph this. And I'm going to do this as follows. Here's my 4. Put 4 here. Here's 0 down here. And I'm going to make a second graph, and I'm going to put it next to it. We're going to make both of those. So this is going to be time t. And this is going to be y. And we're going to make a second graph pretty close by. And on this, we're going to put y and y prime in the same way that we did in that initial picture over there. So this will be y. What I want to do is, let's graph our initial parabola. Let's graph our initial parabola. So here's what we've got. We've got a lot going on. First off, our steady states. We now look like this. Okay. And that one here. And I'm just going to draw one curve, one solution curve is enough. I'm going to draw this one. Or, yeah, this curve, or my other curve below 0. It doesn't really make sense mathematically, it's there, but how do you describe a population with negative fish? It doesn't really make sense. I mean, we'll see that in our solution. So here's where this equation starts to make sense. The next one is a bit more interesting. So our lake has a carrying capacity of 4 fish. So you're like, well, what does that mean? It means that maybe that some of the fish have babies, and now there's 6 fish in the pond. Well, what's going to happen to our population? If you're up at 6 fish, the lake can only hold 4, so there probably won't be enough food, or maybe there's a frog that eats some of the fish. And so, right, who knows what happens in the lake? But could be the Loch Ness Monster lives there too. Anyway, that's probably why the fish have evolved like that, fend off the nesting. So if you have for a while there's 6 fish in the pond, then the population is going to come back down towards 4 fish. Okay? And if for something, maybe Nessie gets really hungry, or you go fishing, and then you leave the population alone, what'll happen to it? It'll increase again back up to 4 fish. Okay? So this is our initial problem. This is your pristine lake up your back door. But now, I want to do one more thing. Let's make the same graph also of y prime. So we're going to have to do a little bit of completing the square. Because we're going to need to see track how these change. So I'm going to do this in blue. If I complete the square, y prime is, what do we say, 4 y minus y squared. I'm going to write that as minus y squared. Are you guys comfortable completing into the square, or does the slope step review is helpful? And then I'm going to, so in order to complete the square, to find the vertex of the parabola, your a term has to be a single 1. But right now it's negative, so what you do is you factor out the negative 1. This gives me a y squared minus a 4y. Take half of 4, or negative 4, what do you get? Negative 2. Square it, you get 4. So I'm going to make that note. So we take negative 4, you multiply it by a half to get negative 2. That number is important. Then you take negative 2 and you square it to get 4. That number is important as well. The second result goes in the first box, plus 4. Then you always have to balance this. How much did I really just add or subtract from the equation at this point? I didn't add 4. I added negative 4. So to keep the equation balanced, I would need to add 4. Negative 4, positive 4. If you distribute all that out, it'll be right back to where it started. So then, this is the beauty of this little process. Now you use your first result. Oh, I'm probably off the camera. So then, come over here, and you use your second result. Y, these are primes. Y prime is minus 1, y minus 2, parentheses squared, plus 4. And then, this is where you use the negative 2. Goes right there. So both of those steps are needed. Now, just a simple picture. It's going to look like that one. Now we have specific numbers. So let's take a moment and graph that. I have a vertex here of 4. And I have solutions of 0 and 4. This is negative. Oh, wait. I have a vertex. My vertex is, you change the sign on the piece in the parentheses, so that's 2, 4. 2, this is 4. Right in the middle would be 2. I just do those dotted lines so my graph looks reasonable. Any questions so far? All we're doing is putting numbers into the idea that we first developed. But now, yes, something?
Zero is steady state. Okay. Does anything actually go towards the steady state of 0, or does it only go up a steady state?
Oh, that's a good question. So did you hear her question? She's asking about this region down here below 0. And what you can see is we have a steady state. We have this steady state here of 0, right? Notice, but let's look at the steady state of 4. the steady state of 4, what happens to the solutions? They all tend towards this. So we haven't talked about this word. We're going to be seeing it soon, so you might as well. This would be called a stable solution. And everything's trending towards it. You know where you're going to end. But notice this. If I'm just slightly above 0, say I took a whole bunch of fish out, I ate them, and then I left the lake to be for a while. So I was way down here. Where would my solution go? Yeah, it would eventually, it's going to have an inflection point somewhere on this dotted line. So it's going to come up and do that as well. So it's going away from 0. And if I start below 0, we said it's decreasing. So wait a second. Every single solution around 0 leaves at 0. This is an unstable solution. So 0 would be an unstable solution. That's a good question. I almost forgot. Let's go fishing. Let's go fishing and see what happens. So we're going to go fishing in purple. I hope that the colors are easily distinguishable. We're going to need to take a look at these. So here we go. Let's go fishing. Fishing. So here's what we do. We're going to say y prime equals, I'm going to write the problem down again. It's 4y minus y squared minus h. This is the general form. And what we call this is, this is called the logistic equation. Logistic equation with Arvist. That's what the H stands for, Arvist. Arvist. Fortunately, it's a small lake, so the problem isn't too difficult to manage. Let's try something. Let's try H's 1, 2, and 3 and see what happens. 1, 2, and 3. Now we're going to do this a little bit differently. We're going to use our understanding of transformations and parabolas, and we can make this a lot easier on ourselves. We're going to keep those graphs. I'm going to go over there. Let's check. Okay, and we're going to do this. So this is the purple part of our problem. Now you could solve that every single time, and we'll get you started. So we're going to, let's just solve this once. Y prime equals, I'm just rewriting it. I'm going to write it this way, minus y squared plus 4y minus h. Let's complete the square on this. So take a moment, you do that, I'll do that. Hopefully we'll come up with the same answer. I have minus y squared minus 4y plus 4 minus h. So I'm going to rewrite that as minus, this is 1y minus 2 squared plus 4 minus h. I think that's right. That's right. So what we have, our vertex has because let me write this, vertex. Our vertex is at the point 2, comma, 4 minus h. If I take one fish from the pond, what changes in my picture over here? So let's try this. H is 1. When h is 1, then my vertex becomes 2, comma, 4 minus 1. Now you might say that was pretty simple. And you could find the zeros of it. It's really simple. We could set this to 0 to find the steady states. Well, actually, why don't you do that? Would you guys do that for me for a moment? Put 4 minus, okay, let's get everyone on the same page. 4 minus 1 is 3, okay, I like that confidence. And then solve, set this to 0 and solve and tell me what you get. So solve, find the steady states. So find steady states. H is 1, find steady states. Find steady state. So if you guys would do that for me, that'd be great. Yeah. We're going to show you. Hang on. You have to see how you have to see the pieces, and then I think you'll. Then the questions will make. I think they'll be useful. Did you get it, Hans? Who's got my solutions? I didn't want to do it just because I have a feeling there's a square root of 3 involved. Those intimidate me. Square root of 3? I'm not, look, so let's see, we put that to the other side, we get a minus 3. We multiply by a minus 1, that becomes a positive 3. We take the square root, so we get, oh yeah, I think our steady states are going to be y is equal to 2 plus or minus the square root of 3. Is that what you got? Anyone get that yet? Someone getting that?
Yeah.
All right, let's grab our purple picture. So I think the square root of 3 in rough numbers is about 1.7. Okay, it's about 1.7. So if I take 2 and add 1.7, it's right about here. And if I take 2 and I subtract 1.7, I'm probably about there. Notice that the vertex, the vertical aspect, axis of symmetry, doesn't move. It doesn't go left or right. It stays put. What happens as you start fishing is your parabola looks like this. Oh, wait a minute. If that's what's happening then, so my parabola has moved down, and so my steady states have changed. My steady states for the purple picture now are something more like this and like this. So now I have purple steady states, and this is going to be a lot of color here pretty quick. Looks like it was decorated by unicorns. But what would happen to my solution? Notice now that it's moved up a bit. So if I'm down here, my solution is still negative. So it's still going to tank. If I'm in between here, my solution, I can start at some point. My solution again has that nice pretty S curve. But it doesn't go up as high this time. Because I'm constantly taking out a fish each year. And so the maximum carrying capacity of this population is decreased. But notice this. Notice now that if we get down to only a few fish, what's going to happen to our population? You're like, there's still fish in the lake, right? But what happens to them? They die off, right.